Okay, in this video I'm going to give you a brief overview of assemblies and how we set them up. So the first thing I'm going to do is I'm going to go File, New, to Assembly and click OK. Now an assembly file links to all of our part files. Okay, so an assembly file doesn't contain the parts, it just links to the parts. So we need to make sure that when we save this in the same folder, the same directory as all of our parts, so we don't break those links. We also need to make sure that we don't change the names of the files, i.e. the parts, in that folder, otherwise again it will break that link. Okay, the first thing I'm going to do, so I just adjust my screen slightly so we can hopefully see, is to begin a new assembly, is to browse and find a part. So I'm just going to go to the browse and I'm going to find a part. I'm just going to grab the radio project and I'm going to start with that. Now again, just as if you were, if you had a load of parts on a table, which one would you pick up first? If you're building a Lego model or something, think about the approach we're going to take to building our model, our assembly. So because of the radio, I'm going to take maybe the outer shell first, because that seems the most logical part to start with, the large base, and then I can start building assembling the rest of my parts around it. Okay, so click to insert your first part. Now, assemblies work using a lot of mates. Now, mates is where you position two components together relative to one another in various different ways. Okay, so I'm going to start off by inserting my outer shell and placing that into the assembly. Now, the first part, it doesn't really matter exactly where that is, because we're going to start putting everything relative to it. So I'm going to go Insert Part, Component for my second part, browse and find that, and let's take the front plate as my next part. Take the biggest items first that we can put in. So I'm going to put it roughly there. Okay, so the second part has now come in. And it's come in a bit randomly. We can click this component, we can move it around anywhere. At the moment it's not constrained in any way. Now what we really need is we need for each of our parts to be constrained basically in the three axes, the X, Y and the Z axis. If it's not constrained in all of those three axes, it means it can still move in one of them. Okay. So to do that, we go onto this Mate tool at the top, Mate here, and it gives us a number of different options. But ultimately, what it's just asking us to do is it's asking us to click two surfaces, two edges, or something like that, and we're going to set a mate to that, some sort of constraint. So it could be coincident, so these two surfaces are touching each other. They could just be parallel, perpendicular, tangent, concentric, or you could just lock your part into position. So I'm going to first of all click this outside surface because I want that surface to be touching this inner surface in here. So I'm going to click those two surfaces and you'll see that they come together. Now I have a little toolbar here that's asking me, do I want to make them coincident, i.e. touching? I can make them parallel, I can make them perpendicular, or I could set a distance. So for example, if I set a distance, I could then define, I don't know, 10 millimeters, so they're offset from each other by 10 millimeters. I could set an angle, or so on. I'm going to make these coincident, because I want them to be touching each other. I'm going to click the tick, and that puts in my first mate. So you see my first mate is down here, a coincident mate. Now, if I just scroll around, I can still click, sorry, I'm going to clear that. I can still click to move that part around. However, if you notice, you can move it in any direction, but it will always be coincident to that front surface. Okay, because I've put in that first relationship. Now, as you can see, I can still move it around, so I need to constrain it a little bit more so it's not just floating all around in this area. So maybe we might take this edge here, so I now might click on this edge here, and click on the inner surface here, mate those two together, make those coincident, so I can keep that on the coincident, click the tick, and now I've added in a second mate. So if I click to drag that, sorry, I actually deleted when I was doing that first one. I accidentally deleted my first one when I was trying to show you how to move it around. So you can add in that first one back in again, so you can So now you see I've got the two mates in there, my two coincident mates, and I can click and drag that, and you see, because I've constrained it on the right hand side and I've constrained it to that front surface, all I can do is move up and down, and that's the only movement I can now do. So as I said, we need to constrain it in our three axes, our x, y and z, and so the last thing we need to do is constrain it in the z axis so it doesn't move up and down anymore. So nice and simply, I can just click on that bottom surface here, scroll around, click on the bottom surface here, coincident, I want that coincident, click the tick, and there we have it. Now if I click, I can't move it at all because it's been constrained in those three axes. If I want to remove any of those mates, I can always click on them down here, and I can click to highlight them to show me what is actually mating together. So you see it's highlighted that blue surface and that inner face, it's highlighted the bottom, and it's highlighted the edge there. I can always right click to delete those if I don't want any of those mates, but if I'm happy I can click the tick again, and go back out into my normal part view. So mates are really quite nice and simple and straightforward. However, the important thing is to know what you're clicking and not just click randomly at random parts as you're going along. I'm just going to insert another component, browse to find my component, and I'm going to just pick up the speaker here and insert that. Okay, so here's my speaker. Again, it's coming a little bit randomly, not quite where I want it to be, but that's fine, because we can go to mate and set some constraints. Now, anything with a circle, we can use this concentric mate. So a circle, if you line two circles up with each other and you use concentric, it aligns their axes. You can basically just see from this little icon you've got two circles overlapping each other with their centres in the same position. So, the first thing I want to do to line these two is I want that edge there, pick up that edge there with this edge here, and if we line them up we can go to concentric, and that lines up their axes so they are now centred together. So you see this time I haven't gone for coincident, this time I've gone for concentric because we've got a circular item, and click the tick. Now if I try and move this, I can only move this along that axis now. You see I've constrained it to that axis. I can move it up and down that axis, and I can rotate it still, but so we still need to have our three reference points. However, I can only now move it up and down that axis. Now at the moment, don't worry that it's facing the wrong way around, and often we bring in parts and they're facing the wrong way around and we want to flip those around. So don't worry initially. Just start your next mate. So I know that I want that surface there to be coincident, i.e. touching this surface here. So I'm going to click this surface here and this surface here. Now it's made them touching, but as you can see it's made them touching in the wrong orientation. I actually don't want them that way, I want to flip them around. If this happens, don't worry, whichever part you're on, there's this little mate alignment box down here that means you can flip it around. So this one is where they're aligned facing the same direction, this one is facing opposite directions. So we can click that, it's just telling us that we've done it. We flipped it around, so we can flip that mate around so it's facing the other direction. Okay, so we can always do that, we can flip it back around again, don't show that box, or we can flip it around again. Okay, once we're happy, we can OK that. Now, at the moment, I can just still spin it around. That's the only thing I can do. Now, to be honest, because this speaker grill is circular, we've got this pattern inside, it probably doesn't matter exactly where that goes. So we can probably leave this at this point now. If, however, maybe you were doing a button or something like that, you might want to line up where those buttons are. So in which case, you could maybe pick a flat surface and line up with a flat surface. So when you're creating a mate, in an assembly, you can line up different things. So you can either click, if you click on an edge, you can line up with edges. If you click on the surfaces, you can line up surfaces, and you can also use datum planes. Now these are really useful. So, for example, I'll just expand my model tree. You could line, if you needed to line something up and you couldn't find a surface to mate it with. So just an example of this, maybe the handle of this radio is quite a challenge. You can't find a flat surface easily. Instead we can use datum planes. We can click on one datum plane, so we go into our mates. We can pick up one datum plane, we can expand our model tree here, we can go to another part, and we can pick up another datum plane here maybe, and we can assign some sort of mate to them. Okay, I won't do this now because I can't actually assign a mate to that. Parts can be over-constrained, and if you've got an over-constrained part, i.e. maybe if you put 4 or 5 different mates on a part, it won't let you do that. Okay, so once you've constrained it in the X, Y, Z axis, it will fix it in that position, and it won't let you do any more. If you're trying to do something that it won't let you do, because you've over-constrained it, just look down here at the bottom of your model tree are all of the mates that you've got in that whole assembly. You can just hover over each of them one by one, and you can see what they are. If one of those is wrong, or if it's affecting the rest of your assembly, so say you've mated something accidentally, you've just randomly clicked some lines or some edges, okay, then you can click on that mate and you can right click to delete it. Solidworks nicely tells you what's actually happening. So you see I hover over here, this mate here, it's showing me that that purple surface and that orange surface are joined together, and it's telling me which parts they are as well. So it's really clear what's actually happening. So this is just the case if you kind of get in a bit of muddle of going through your model tree, going through all of those mates and working out which one you don't want, which one's causing you an issue. Okay, so lining it all up, relatively simple, nice and straightforward to create that assembly.